In this video, we're going to explore ellipses that are not centered at the origin. In other words, they're centered at another point, which we're going to call HK. So our HK is not 0, 0 in these examples. I have put the formula that we use for an ellipse at the top of the paper in black here. And we sometimes will have the a squared first and the b squared second. Sometimes we'll have the b squared first and the a squared second. So we won't really know until we start sketching it which one it's going to end up being. But we've been given 2 points for the vertices and 1 point for one of the foci. And so let's plot those and start to sketch where this thing is going. So I've plotted these 3 points, 1, 6, 1, 16, as our vertices, and I've done those in red, and then I did one of the foci in green. So we can find the other foci and we can find the center based on this information. The major axis we can tell is the distance between the 2 red points, the 2 vertices, and that is a distance of 10 units, which you'll just have to count, or you can subtract the 16 minus 6. The minor axis we don't know yet because we don't know our b value. Our c, that puts our a at 5, and our c would have to be the distance between the center and the focus. Well, we don't have the center yet, but think about where the center would be. It would be right in the middle between 6 and 16. So what you can either count 5 units down or 5 units up from the vertices, or you could average them if it was a difficult number. You could take 6 plus 16 divided by 2, and you could get the actual point that way. So 6 plus 16 would be 22 divided by 2 would be 11. So we know 111 is going to be where the center is. But again, you don't have to average them. That would just be one option. You could find the middle by just counting that the major axis is 10 units, so we have to go either 5 units down from the top or 5 units up from the bottom to get our middle. So this is our center, and that will represent your HK. So we'll get that in a minute, but we could write that our center happened to end up at 111. Then our other focus has to be, if you notice, the distance between the vertex and the focus is 2 units, so you can come up 2 units in the other direction to get the other focus, so that's also 2 units. And that will put it the same distance from the center, 3 units each way from the center. So what that means is the C value, which is the distance between the focus and the center, would be 3 units. So again, this isn't about memorizing a bunch of formulas. It's really about counting and just using logic and the definitions of what A, B, and C represent to kind of help you figure out what the A, B, and C values are, which will then give you your equation. We can't draw the ellipse yet because we don't know how wide it's going to be. We only know how tall it's going to be. And so what we want to do is figure out what our B value is. Remember, the formula is c squared equals a squared minus b squared. That's always the formula that goes with an ellipse that helps us define c or a or b. In this case, we're given c, and so this would be 3 squared, which is 9. And we're given a, 5 squared, which would be 25, but we're not given b, and so we're just going to leave the b squared there. Now we're going to solve for b squared. So if we subtract 25 from both sides, we get negative b squared equals negative 16, which we then can just divide both sides by negative 1 and get b squared equals 16, and that means b must be the square root of that, which is 4. So with the information we have about B, we know that B is the distance between the center and the co vertex. So now we can count away from the center 4 in either direction. So that would put us where the purple points are on our picture. So that is where the co vertices are. Now we can draw our ellipse. We draw it through our vertices and our co vertices. This particular ellipse is taller than it is wide because our A value is 5 and our B value is 4. And so that means since it's a vertical ellipse, that the A needs to be in the vertical direction, which is the y-axis direction. So the A actually needs to be under the y, not the x. So we're going to switch our formula at the top, and we're going to put the A value under the y and the B value under the x, because this is a vertical ellipse. It's longer in the vertical direction, which is the y-axis direction, so it goes under the y. If you had to name all the important points as ordered pairs, we already have the two vertices here. We have one of the foci here. If we needed to name the other foci, we would look where it's located, and it looks like it's 1, 8. So that's how we would name the other focus. If we had to name the Co Vertices, we can see that one of the purple points is at 5, 11. And another one of the purple points is at -3, 11. And almost always they'll have you name the equation of the ellipse that's been drawn. And so what we have is x minus h, and remember the center is your hk, and so the h is always the first value in the center, so we'll put that next to the x. And next to the y, we're going to put the k, which is always the second value of your center. So it's always x minus h and y minus k. And then we'll put a plus sign, because an ellipse always has a plus sign, and it always has equals 1 out to the side. And then on the bottom, we'll put the b squared first, according to the way we wrote the formula. And the b squared is 16, and the a squared is 25. Now we have the equation of an ellipse that's not centered at the origin. The picture on this page is something that I can get to you if you contact me. You can also screenshot it. It's not super clear on here because it's so tiny. But this is a great page that summarizes all the conic sections. And what I wanted to point out is, yes, this summarizes everything, but I don't want you to memorize all the little formulas. For example, you've got a vertex that says h plus or minus a, comma k, and the co-vertex is h, comma, k plus or minus b. Those you'll just logically figure out as you sketch it, but I did want to have a summary page that you can look at to kind of see all the patterns and how everything works for each conic section. So just as an example, the last ellipse that we worked was the type that had the b squared first and then the a squared. And notice I say over here, in an ellipse, a is always bigger than b, and a is the distance between the center and the vertex. I also say in this formula that if you're in either one of these, the formula to help you find c, which has to do with the focus, is c squared equals a squared minus b squared. The difference is if it's this one here will be a horizontal ellipse, and this one here will be a vertical ellipse. And therefore, when you're doing the focus will always be in the direction of the major axis. And so on one of them, the focus, you're going to add the c value to the h, which is like your x value. And in this one, you're going to add the c value to your k, which is your y value. And so where you add that c will be different in each type of ellipse. But all that will make sense when you draw it to where you don't have to memorize these formulas. A couple of other things I point out on here is, yes, this type of ellipse is vertical. The one along the top row is horizontal. But in either case, the length of the major axis is going to be 2a, and the length of the minor axis is going to be 2b. And that's pretty much all the parts to an ellipse that you need to know. Let's look at the example that we just did. So let's say you were given the equation. So I went ahead and filled in the values that went with the equation on the previous page, that it's x minus 1 squared over 16, and it was y minus 11 squared over 25, which tells you that your a value is 5 and your b value is 4. So say we didn't have all the information except we had the equation first this time. So immediately you can tell that your center is 111 because it's always in the HK spot of your equation, H and K. And since the formula says minus, you'll always end up using the opposite looking signs of what you see there in the formula. Then what happens is, if you need to add a to something, what you're going to add it to is the y value, because the a was under the y. And so that's why it says here to add the a to the k, because that would be the y value. And so we're going to take the 11 and we're going to add 5, and we're going to subtract 5 as well, because we're going to go do it in both directions. So if you needed to find the vertices, you would know to add 5 to the 11, which would be 16, and then you would add or subtract 5 from the 11, which would be 6. And if you'll notice on the previous page, these were our vertices. Our co-vertices are adding the 4, which is your b value, to the x, because the 4 squared is what was under the x. And so we're going to add it to the x part of our center, which is our h. And so what we're going to do is we're going to add and subtract 4 to the h value, and that's why it says here, you can barely see it, but it says the co-vertices, you'll add the b value to the h and subtract the b value from the h, but the k will remain the same as the center. So the center had a k of 11, and the h, we're going to add and subtract 4 to the 1, or the h value. So when we add 4, we get 5, and when we subtract 4 from 1, we get -3. And you'll notice in the picture on the previous page, those were our co-vertices, 511 and -311. And then if you needed to find your focus, it says right here, you'd be adding the c value to the k, which would make sense because the c value has to always be in the same direction that the a value is, because the focus is always on the major axis, and so is the a value. So c and a will always be in the same direction, and that would be, in this case, since the bigger number's under the y, the c value has to go in the y direction. So you would add it to the k, not the h. And so if we go from the center and we add the c value to the k value, you would have 11 is your k value, and in this case you're going to add and subtract our value of c, which was 3, which, if you didn't know that yet, you could use this formula that c squared equals a squared minus b squared, and you could get 3. That c value is going to be added and subtracted from the k part of your center. So you have 11 plus 3 is 14, and your 11 minus 3, which is 8. And if you look at the picture, those were the spots where our foci were. So hopefully that will help you kind of relate this page to the previous page and kind of the logic behind it. For the second example, I don't have time to explain it, or I'd exceed the length of this video. But notice all my steps, walk through at step 1, 2, and 3, and 4, and then pay special attention to what happens when A, B, or C does not come out nice and you have a radical. Notice the yellow highlights and how we write the point in the correct form in the yellow highlights.